Okay, this standard review. Now we're through this standard. We know pretty much covered it nook and cranny. Determine whether each function example of exponential growth or decay, then find the y-intercept. This is your starting number, and then you're multiplying by 4 to the x power. 4 is bigger than 1. It's a growth. Now your y-int is easy to find. You simply make a coordinate where your x is 0. And then I take 2 times 4 to the power, wait a second, yeah, I insert 0 in for x, but anything to the 0 is 1, and if I take it times 2, it's 2. There's no coincidence that it always ends up that initial amount, okay? So those are your two answers, okay? Now, 3 is your initial amount. 0.25 is less than 1. You're multiplying by a number less than 1. It's a decay. Okay, then your y-intercept. I think it's going to be 3 because that is 1. 3 times 1 is 3. Okay, some of you guys that do not understand fractions, you simply take 7 divided by 5. That looks like it's bigger than 1. Okay, so that's growth. Okay, that's 1 times 25 over 7 is 25 over 7. Okay, you can leave it improper. It can be a mixed number. I don't care. It'd be 3 and 4/7. Okay, next one. 1/4. Well, I don't believe 1 divided by 4. Nope, that's decay. Okay, so 0.5. It's got to be, because that's 1. Anything that's 0 is 1 times 0.5, 0.5. Okay. All right, now the graph. Okay. Identify the function, graph the function, identify the domain and range. Okay, we will not be needing the table over here. I don't need to rewrite this. I do need to parenthesize my independent variable with its exponent and the base. Okay. This is an exponential function. I'll just input integers 2 through -2, and there's also an asymptote. You forget that, you're losing points. Okay. It starts at 0, but it might change. Probably going to change. Now, just do mental math. 3 to the second power is 9, and that would be 1/9. 3 to the first is 3, 1/3, and that's 1. Now, 3 to the x is your parent function. Now, plus 1 with the x, you need to minus 1. And then with the y, you times 4 minus 5. Okay, so 2 minus 1 is 1, 1 minus 1 is 0, -1, -2, and -3. Now we times 4 minus 5. 9 times 4 is 36, but I minus 5, 31. 3 times 4 is 12, minus 5 is 7. 1 times 4 is 4, minus 5 is -1. 1/3 times 4 minus 5 is going to be -3 2/3. Let me double check that. Darn, I'm good. Okay, then 1/9 times 4 minus 5 is -4 5/9. Not that I'm going to graph those anyway, but at least I have them. So 0 times 4 is 0, minus 5 is -5. So your asymptote's now -5. So 131, 5, 10, 15, 20, 25, 30, right there. Now set up your asymptote. Asymptote's -5, but remember we're going by 5, so -5's here, and it's a horizontal asymptote. Okay, 0, 7, 5, 7, -1, -1, so left 1, down just a tish. That's good enough. Okay, I know exactly, I can sketch this now. That way it goes up. Now I could keep going that way. I could go 3, 4, 5, 6, 7. Okay, it goes that way. And then here, all that's going to do that way is just get closer to -5. Okay, domain and range. Now it looks like the arrows go in both directions, left and right, so the domain's all. The range, there's that -5 for your y, and you are above it, so that's greater than, but not equal to. Okay, now this one I may be willing to let you actually use this as a sample problem on your test. For one I screwed up, I need a parentheses there, otherwise you can't tell. Put a parentheses with your x. Now you have a table off this side, because first you're going to write an inverse, okay, when you have a logarithm, because you have no idea how that's going to graph. First you switch the x and the y. Then you see that see to it that your log's isolated. Get that -1 out of there. You +1 over here. Now you rewrite it without the log. Whatever's in parentheses goes by itself. 3 to the x plus 1 power. Okay. Now set up the table as though you're going to graph it. Same as last problem. Asymptote, we always start with y as 0. 3 to the second's 9, that'd be 1/9. 3 to the first is 3, 1/3. 3 to the 0 is 1. Okay, +1 with your x means you -1. And you're not going to do anything to the y's, okay? They still stay put. That's what they have. 2 minus 1 is 1, 0, -1, -2, -3. But I had to switch the x and the y, so I don't want to graph that. I need to flip-flop them, okay? So 9, 1, 3, 0, 1, -1, and now the asymptote is now an x. So instead of 0 here, you're going to go 0 here, and that is your asymptote, okay? So 9, 1, okay? So 2, 4, 6, 8, 9, okay? And then 1, and the asymptote 0 is 0. You don't have to. 3, 0, 2, 3, 1, -1, okay? Okay, now your domain and range. Now the range is now all, and now the domain is x and 0, and all points are to the right, so greater than. Okay. It's just the inverse of what you did before, okay? But you have to rewrite it and so forth. Okay, number 7, that's supposed to be a 3. It's 5 to the third is 125. You don't have to do anything here. You just have to memorize how to write. I know that sounds bad, memorize. We can't have that in school, even though that's part of school. But write the equation in logarithm form. Whatever your power is goes here, and then you write the word log. Okay, base 5, 125. It's just knowing what you have, okay? I'd have to multiply 5 out 3 times to get to 125. Same idea on the next one, okay? So your exponent goes here all by it. When you write a logarithm, that equals your exponent. 10 and then 0.001, okay? Okay, next one, you're evaluating the logarithm. These are going to be quick because the first way works. You can only go COB if you can't get the first way to work. 36, that's 216, okay? So I've found it, it's 3. That's 625, that's 4. That's 2, okay? Now if you have a 1 over the top of it, it's going to be equal to a negative, and you just multiply 3's out to 27. 3. So as you can see, a lot of these problems don't take exactly all that long. Write the expression as a single logarithm, okay? Means you need to write log base 2 one time, make a parentheses, and you use multiplication division. So you have A, minus means divide by B. Now the 3 now acts as a power to your A and the 2 to your B. Done. Okay. Expand the logarithm. Now you're doing the opposite of what you did here. You make the parentheses and you need 3 logarithms because there's 3 factors. Okay, 3 times means plus. And then we have x to the 3rd, but I'm going to erase that 3, and now that comes around to the front, right there. And then plus y to the 2nd. I'm going to erase that 2 because that needs to now come around to the front. It's like the opposite of right there. These two are on the same page because they go from one to the other. Okay, equation solving. Okay, solve each equation. You're solving for x. Now, x is the exponent. Make sure you don't have anything outside the power expression. You don't. Okay, so there are 2 ways to do it. There's the COB if we need it. You got to figure out what 3x is equal to. You can divide by 3, but you got to figure out what the x, 27 to the what power is 81. That's too high to be 81 already. Okay, so change of base is log over log. 27 on bottom, 81 on top. Okay, 1.33. Don't forget to divide by 3 though. And that's 0.4. Repeating, 1.33 divided by 3. 0.44. Okay, next one again, you're solving for the exponent. The exponent's x minus 1 with a base of 3. So x minus 1, we got to figure out what power we have. Is it possible to multiply how many 3? 3 to the what power is 24. 9, 27, that's too high. So I do my COB. Change of base is what that stands for. So 3, 24. Okay, 2.89 plus 1, that takes us to 3.89. Now I screwed up, I forgot to put a parentheses right there, okay? Now you need to rewrite this so it's an exponent, not log, okay? You go, kind of like the graph, you go from your L to your parentheses. You can't have that 2 there, but it's not minus 2, it's in front, so it's times, so you divide. You have to do that first. Now I rewrite it. Whatever's in parentheses goes by itself. Base 10 to the 2nd power. Remember, this is your exponent, okay? When you have a log, whatever's all by itself, that's going to be your exponent. On the other side of the logarithm's your power. The base would be 10. Well, that's easy. 10 to the 2nd's 100. So one of those that doesn't take long. A lot of these problems don't take that long. You just got to be ready for them. Okay, so if you see E and you have to solve an equation, write ln. You're going to have to use it, the natural log. Okay, again, I would rather call it NL, but ln. Okay, so first off, solving for the exponent, okay, with a base of E. First you divide by 2. Okay, it's time to say goodbye to Mr. E, ln. Just put it over the top, because those cancel, you now have 3x. And we just find the natural log of 8 on our calculator. 2.08. Divide by 3. .69. Okay, so if you see the natural log, you're going to have to use the e to the power at some point. Okay. First, you got to get this so there's only one ln. So ln, make a big parentheses. You're going to have x plus 1 you can have parentheses within parentheses times x minus 1, because plus means times equals 4. Now it's time to get rid of Mr. ln, so I go e to the bottom left. Those cancel. Now you need to FOIL that so you know what goes. Simplify that. So you take x times x times negative 1, 1 times x, 1 times negative 1. So that's x to the second, negative 1x, positive 1x. Now if I add those, they cancel. So that's good when they cancel. So that side's going to now have just x to the second power minus 1. And now I got to, don't write 4 down, you got to raise e to the power of 4. Okay, 54.60. Then you just got to add 1 and square root. Okay, remember when you square root, it's a 2. Okay, so it's a positive negative. Okay, so I'm going to hit 2 so I know it's a square root. Second caret 55.60. Okay, 7.46. Okay, it did end up as a quadratic equation, but it was an easy quadratic. Okay. Okay, the old compound formula. I deposit $300 in a savings account. The account earns 5% interest each year, compounded quarterly. How much money will be in the account after 12 years? It's up on the board, brother. Don't need a units box. I know exactly what I'm using. N times T. So what do all these are? P is your deposit, 300 bucks. R is your percentage as a decimal. Okay, so 0.05, not 1.05. The 1 is right here, okay? Because I can't add it until that it's divided by n, and n is 4. Quarterly, there's 4 quarters in a year. T is 12. Yes, that's good news for me when I know all these. Easier problem. P is 300. R 0.05. N is 4. N is 4 times 12. Okay. Well, we know that's 48. Now let's get rid of the parentheses. So you got 300 times. You are going to divide. Division comes before addition in order of operations, and I add the 1. Don't forget to add the 1. Got to do this, then this. 1.0125 to the 48th power. That's a straight shot into my calculator. $545. Okay. Okay, I like it when I know all that stuff. However, sometimes I don't know the T, because that's what I'm trying to figure out. Now I call it, if I don't know T, I use X, because I don't like T as a variable. It gets mixed up with a plus sign. Okay, you deposit $500 in a bank account that earns 3% interest each year, compounded quarterly. How long will it be before the account reaches $1,000? So I use the same formula. Okay, so A, and what is all this other stuff? Okay, P, R, N, and T. P's 500. R, 3%. So it's going to be 0.03. N is still 4. T is X, okay? So I go 500. 1 plus, then the rate 0.03 divided by 4. N is 4, and then we'll just put X, okay? Well, if I got to solve for X, then I have to know the A, okay? The A is where we ended up at, okay? We know what we end at. It's like the opposite of the last problem. You know where you end at. Last problem you were figuring out where you ended at, so 1,000. we're going to get rid of the parentheses then. We divide first, then add 1. So 1.0075 to the power of 4x. Okay, if you have to solve for the exponent on these problems, you might as well set up your COB, because you're not going to be able to do it the first way where you multiply out, because if the base is a decimal. Okay, so 4x equals, okay, but I have to undo the times 500, okay. So that's 2. Okay, now I use my COB, log over log. You can't use your COB until you have the base and the product. You can't have two numbers floating outside, okay? By the way, at this point, you know 1.0075 is the bottom log, but you don't know what's on top because you have to divide by 500, so that's 2, okay? So I take log 2 divided by log 1.0075, 93, then I divide both sides by 4. 93 divided by 4 is 23.25. Go 24 on that, 24 years. Because 23, you'd still be under 1,000. 24, you'd take you over. Okay, now this problem, sorry about this, the paper ripped, so I had to rerun it. You buy a boat for $4,000. The boat decreases in value by a constant percent each year. After 3 years, the boat is worth $3,217. What percent is the boat decreasing in value each year? You ain't using you don't use that, okay? It's not an interest problem. Do a units analysis. You got money in years. Years is X, money's Y. Dollars per year, there isn't a dollars per year, it's a percent per year. But you don't know the percent, so put question mark. And if you don't know the percent, that's going to be your B. So down here, you're going to be solving for B. Now, if you're wondering, what the heck are you talking about B? Well, remember this, it ain't a line. So I use the exponent. A times B to the power of X equals Y. Now, you're going to make yourself a little side note that A and Y are the same unit, okay? So,
I'm just here to check and make sure.
I'll just lock my door. I'm done after I'm done with this, okay? So dollars is Y, so the A and Y are both your dollars amounts. A is your beginning amount. Y is your ending amount. That's why I like to set the Y over here, okay? A times B to the X power equals Y. Now the B you don't know because that's your percentage, so B is unknown. X I know, that's 3. Okay, and I'll solve it. I'm going to divide by 4,000. So B to the third, .80. You get rid of a power by making a radical, it's a 3. Okay, so this is how you punch in 3 second caret 0.80. Now put 0.93 down, but to find the actual percent, there's two things you have to do. And you can't do them at the same time. First you minus 1, because it's like you're taking the 100% out of the mix. Negative 0.07. Then move the decimal forward twice, because that's how you convert a decimal to a percentage. Negative 7. Negative 7% is the answer.